In this lesson, we're going to look at solving area and perimeter problems. Now, to start with, just as a review, the area of a shape is the amount of two-dimensional space that the shape occupies, like if you're going to tile it or shade it in or something like that. So area is generally done, sort of units might be in like meters squared or centimeters squared, or square feet, feet squared, or square feet. For example, a meter squared is just a box that's 1 meter by 1 meter. Centimeter squared is a 1 centimeter by 1 centimeter box or square, and so on. And then perimeter, of course, is just the distance around an object. So we have a formula sheet that you can use. It's right here. Hopefully you have one of these. It has we're just going to be looking at the first side today, which has perimeter and area formulas of a circle, parallelogram, rectangle, trapezoid, and triangle. Now, please keep in mind that perimeter formulas aren't always super useful. A perimeter of a shape is really just the distance around the outside of the shape, and often it's easiest just to add up all the sides that you have and figure out the perimeter that way. The only perimeter formula that's maybe useful is the perimeter of a circle. The perimeter of a circle, which is called the circumference, the distance around the outside of the circle, is always just the diameter of the circle times pi, or 2 times pi times the radius, if you want to use the radius instead. Of course, the radius is just half the diameter. In this first example, we see a pool in a backyard, and the pool is a circle, and we're asked to find the area of that pool, which looks like it has a diameter of 10 meters. So according to that formula sheet, the area of a circle is pi r squared. And our diameter is 10 meters, which means our radius is half of that, which is 5. So the area here is pi times 5 squared, like so. Now pi is approximately 3.14, or you can use your calculator, a pi button on your calculator, to get an even more accurate answer. I'm just going to do all this work on my calculator. Well, 5 squared is 25, so it's going to be pi times 25. And then doing that on the calculator, I can get an approximate answer, 25 times, and this calculator does have a pi button right there. I get about 78.5 meters squared. We'll talk more about the units later on, but for now we know that when you're measuring in meters, your area will be in meters squared. What's the area of the lawn surrounding the pool? So notice that the lawn is a rectangle that's 20 meters by 14 meters. But of course, the lawn doesn't include the pool. So what we do is we calculate the area of the lawn, and we just subtract the pool's area, which we've already calculated. So that area will be area of a rectangle, of course, length times width, 20 meters times 14 meters, subtract 78.5 meters squared, which is the area of the pool. So again, 20 times 14, which is 280. So 280 minus 78.5, we get 201.5 meters squared. And that's an approximate area as well, because the area of the pool is not exact. Notice when I take, we talk a little bit about units here. When I take a meter and multiply it by a meter, I do get a meter squared, kind of like how when we multiply x by x, we get x squared. In the next part, we're looking for the circumference of the pool, so the distance around the outside of the pool, which is just pi times the diameter, and that in this case will be pi times 10 meters, which is about 31.4 meters, 3.14 times 10. Okay, and that finishes that question. Find the perimeter of the triangle below. So notice that we want the perimeter of this triangle. We are missing one of the 3 sides. I'll call it B. Now this is a right angle triangle, which means we can use c squared equals a squared plus b squared, Pythagorean theorem, something we talked about in class. But keep in mind that your c value is directly opposite the right angle, the hypotenuse, so that's 25. And then A and B don't matter which side is which. 18.5 squared plus B squared. Okay, now in this case, I'm going to solve for B by subtracting. 25 squared minus 18.5 squared equals B squared. And so that value will give me B squared. And I'm just going to do that on my calculator. So 25 times 25 minus 18.5 times 18.5. Gives me 282.75. So B will be the square root of that answer. And on here, that's my square root button on this calculator. It gives me about 16.8, and we'll say that that's close enough. And then the perimeter, I don't really need a formula for the perimeter of a triangle. I can just add up the three sides here. So our perimeter is going to be approximately 25 plus 18.5 plus the missing side we just found is 16.8. Those are all in centimeters. And just see, that's going to be about 60.3 centimeters. Question 3, we have a semicircle. Now, a semicircle is exactly a half circle. So we know that this is like a full circle with a diameter of 20 centimeters. Well, the formula of a circle is pi r squared. But since we only have a half circle, we're going to divide that by 2. Now, in this case, our radius is half of 20, which is 10. And from there, we do pi r squared. It's 100 times pi, because 10 times 10. So 100, oops. 100 times pi. Okay, and then divide by 2. And you get an area about 157, around that 157.1 centimeters squared. So now we have a question 4, what's a composite shape here. So a shape made up of 2 different shapes. And we're asked for the area and the perimeter of these shapes. Now it appears we have a rectangle, 8 feet by 20 feet. That makes this side 20 feet as well. And then one thing to ask is about this little curved section. We're going to assume that this is exactly half of a circle or a semicircle. And that's a fair question to ask. Is that exactly half a circle? I'm telling you, sure it is. And notice, since this is 8 feet over here, I can do 1 dash to represent feet. Since this is 8 feet, that's actually the diameter of that circle. Let's start with the area. The area of the rectangle is just length times width, which would be 20 feet times 8 feet, or 160, and that's in square feet. And then we have the area of the semicircle. I'll just write A of semi for short, which is pi r squared divided by 2. In this case, that's pi times 4 squared divided by 2, because the diameter is 8, so the radius is 4. And you should get about 25.1 square feet for that. So that gives us a total area in this example which is 160 plus 25.1, or 185.1 square feet. So the area of both those sections added up. Next, we'll look at the perimeter. So the perimeter, this is where you want to be careful and not think too much about formulas, and think about how many sides you have here. So this shape, if you go all the way around the outside, only has 3 sides. The first side, 3 sides, just switch colors here, is 8 feet. You then have a 20-foot side and another 20-foot side. And then we have this curved side here, which I'll call C. And that's the fourth side of the shape. There are only 4 sides. This 8 foot is not part of the shape. You can't just take the perimeter of the rectangle and add it to the circumference of half a circle. It doesn't quite work that way because the circumference of the half circle sort of takes the place of this side right here. So here our C value is half of a circumference. So pi times d, which is pi times 8. But we're going to divide that by 2 since it's only half of the circle. And so that C value, okay, if you do that, you get about 12.6 feet for that. So pi times 8 divided by 2 is about 12.6. And that becomes our fourth side. So then our perimeter ends up being, if you add up those 4 numbers, I believe you get 60.6 feet. In this next shape, we have a trapezoid, and we're asked to find the area of a trapezoid. So let's just talk a little bit about what a trapezoid is. The reason that a trapezoid is a 4-dimensional shape or quadrilateral where exactly 2 of the sides are parallel. So those 2 sides are parallel. I can draw little arrows to show that, and so that makes this a trapezoid. Now, we do have, I mean, one way to solve this problem, we divide this up into a rectangle and 2 triangles and try to find the area that way, or we can use a formula for a trapezoid. So if you look on your formula sheet here, you'll see there is a formula for the area of a trapezoid. By the way, these 2 formulas are exactly the same. Dividing by 2 here or multiplying by half is the same thing. So let's take a look at the trapezoid. We have h, which is the height of a trapezoid, which is the distance between the 2 parallel sides. And then the 2 parallel sides are a and b. So the easiest way to calculate the area of a trapezoid is add a plus b, divide by 2, and then multiply by the height. You're basically calculating the average, a plus b divided by 2, the average of the 2 parallel sides, and then multiplying it by the height to calculate the area. Notice C and D have nothing to do with the area. So if we go back and we look at this, we see that this could be side A, and this could be side B, and then we have a height, which is right here. Now, we actually have to figure out the height of this trapezoid, which is a little bit challenging. So let's think about how we do that. Notice that I've drawn this height right here, so we have a perfect right angle triangle. And there's another one over here. If this side here is 20 centimeters and this whole side is 30, since this B is 10 centimeters greater than A, that must mean that we have another 5 centimeters here and another 5 centimeters here. Also, notice these bars here indicate that these 3 sides are all the same length. So if this top side here is 20 centimeters, this is 20 centimeters as well. And now we can use Pythagorean theorem to solve for h. So c squared equals a squared plus b squared, where c is 20, a is our height, and b is 5. Oops, sorry, b is 5. 20 squared is 400, and 5 squared is 25. 400 minus 25 is 375. So h will be the square root of 375. You can use your calculator for that. It's about 19.4. We're then ready to use the formula for the area of a trapezoid, which is a plus b divided by 2 times the height, and we know everything we need to know now. 30 plus 20, doesn't matter which one's which, divided by 2 times 19.4. Now 30 plus 20 is 50. 50 divided by 2 is 25. So the answer is going to be 25 times 19.4, which is 485 centimeters squared. And it's approximately that because our height was rounded. We have one more question involving trapezoids. So this is another shape that is a trapezoid, and the reason that it's a trapezoid, we assume these are right angles right here. That makes these 2 sides parallel. And now our height is actually this right here. So this is like a trapezoid that's kind of on its side. If you want to think about rotating it, maybe that would help. So the area of this one's actually pretty easy because we have everything we need to know for the area. We have the two parallel sides, A and B, and we have the height, which is 5. So we can just go straight to the formula for the area. 9 plus 12 divided by 2 times 5. Let's see, that's 9 and 12 is 21. Divided by 2 is 10.5. 5. We should get 52.5 meters. So there's our area. Now, unfortunately, the perimeter is going to be just a little bit more challenging because we're missing this side right here, which I'm going to call C. And then we need to add the 4 sides up to figure out the perimeter. Now, I called that C for a reason. This is a right angle triangle right here I've drawn, where C is the hypotenuse. This is 5 meters. And then this third side here, if this is 12 and that's 9, that makes that this side must be 3 meters right here. And so we can figure out C using Pythagorean theorem. C squared equals 5 squared plus 3 squared, which is 25 plus 9, or 34. And so C is going to be the square root of 34. Which is about 5.8. And then we have everything we need to calculate the perimeter. It's just a matter of adding up the 4 sides. 12 meters, the side we just found, which is 5.8 meters, and 9 meters. Gives us our total perimeter. Let's see. Which is about 31.8 meters. Okay, and there you have it. That's it for the lesson here on area and perimeter, and you've got some problems that you can work on now. Thank you.